think about it, language spoken by lakhs of people, zero digital data. But again, it shouldn't be surprising. If we think about Hindi, which is spoken by roughly 10% of the world's population, any guesses what percent of the world's information content accessible through the web is in Hindi? Ideally, it should be close to 10%. The correct percentage is close to 0.1%. So highly underrepresented. So the other thing we know is that the same language is spoken in so many different ways. There's this Hindi saying, "Kos kos pe badle pani, char kos par vani," which inspired this project called Vani that we launched with ISC, where we've been collecting speech data from different corners of India. And the goal is, by the end of this project, to collect data from each and every one of the 773 districts. So we've made data from the first phase of this project collected from 80 districts freely available. It covers 59 Indian languages, and 15 of those languages used to be zero corpus languages. So we're hoping that as we continue this effort, hopefully we'll uncover all of the different languages, dialects, accents. The other thing that our team has pointed out is that it's not just important to understand the language, you also need to understand the culture. When you're responding to a user in Assam, you shouldn't come up with the response in English and simply translate that into Assamese. You should come up with the response rooted in the cultural context. So again, a lot of work that our team is doing right now on that. The other area in which very proud of some pioneering work that has been done by our team sitting in India is on making these models more efficient and elastic. Elastic in the sense that today, in a single model, when you, let's say, have a Gemini, let's say 16 billion parameter model, we build it in a manner that embedded inside that 16 billion parameter model are smaller models hiding. So that if you have a task, let's say a very simple task, who's Narendra Modi? You don't need a 16 billion parameter model to answer that question. A very simple model would be able to answer it. So you can have a simpler model do it. And likewise, our team has systematically gone through the different components of a large language model and come up with a bunch of first of kind methods to dramatically cut down the cost of running these models and energy, which has again led to Gemini models being kind of best of breed. Yes, there's been a lot of, again, excitement around the launch of DeepSeek models, but again, with Gemini, we continue to hold, be at that frontier of extremely efficient models, and very proud of our team in India having contributed to making these models very efficient. And finally, agriculture, right, accounts for over 40% of the livelihoods in India are dependent on agriculture, and that's a field which has not been touched much by AI. So our team has built the first such model that, based on satellite imagery, it is able to identify things like field boundaries, identify crops being grown, and so on. So the idea is to build the low foundational layers of an agri stack, just like the mobile payments, right, in India were revolutionized by this Aadhaar stack, which started with giving a unique identifier, ID, Aadhaar ID, to each individual. Likewise, through our work, we are giving a unique ID to each farm, so that now, when the farmer goes to get a loan from a bank or insurance for a crop, the provider can quickly identify, yes, what is the farmer growing, what is their expected income, and so on, right? And all of those things can be unlocked.